Hi everybody, welcome to Nige Electrical channel. Uh, this time around, we are going to be talking about some electrical components in relation to our last topic, which has to do with line diagrams. This time around, we are going to be talking about some of the electrical components that are being used in the industry, and they are designated line diagrams. So first on our list is fuse. We've got the switch, the normally open and normally closed switch, the thermistor, the lamp, the ammeter, the voltmeter, the diode, the inductor, the battery, or you say the cell, the resistor, the buzzer, the LDR, the ground, the potentiometer, AND gate, the joint conductor, OR gate, phototransistor, NOT gate, the motor, the AC source. So first off on our list is the fuse. In the industry today, fuse is largely used across all electric panel. It is an electronic or a mechanical device used to protect circuits against overcurrent and overload, as well as to assure circuit protection. The fuse is widely used. As you can see, that it is being designated by these few diagrams. However, that it has also got the real images. While fuses are of different types and of different uses, commonly in line diagrams they are designated with these images. Also, we've got our normally open switch, or the normally open contact. Normally open contacts or switches indicate that the switch or contact does not allow electricity to pass through when it is not pressed or switched or pushed. What we're saying in essence is that the switch is always open until it is being pressed. It is always open until it is being pressed. Once it is pressed, it becomes closed. However, it is being created. Normally, it is open in a true sense until it is pressed. If that is clear, we go to normally closed. Unlike the normally open, the normally closed contact is a switch whose typical conditions gives room for current to flow when it is not energized. This is what it means. When a normally closed contact is not energized, current normally flows. Current is meant to flow when it is not energized. However, energizing and activating it will cause the contact to open, thereby preventing current to flow. For thermistor, which are represented with this diagram, a thermistor is a resistant thermometer or a resistor with temperature dependent resistance. It is comprised of the word therma and resistor. Largely it is used in the electric motor and in some other use cases as well. We move on to lamp. Like we have in the industry, lamps are like indicator. We say indicator lamp. When you use them in the industry on the electric panel, when you press a button, when the motor is running, take for instance, the lights can show green, and when it is being stopped, it can show red. When everything is okay with the panel, it can show the white indication. So the lamp is being used for this purposes in the industry. We've got our ammeter. An ammeter, which is an abbreviation of ampere and meter, it measures current in a circuit. That is the simplest basis. When you are measuring your current using an ammeter, you measure your current in a circuit using an ammeter. One of the common, the same thing goes with the voltmeter. The voltmeter is an instrument for measuring direct or alternating electric current voltage. It is often graded on in volts, millivolts, and kilovolts. The ammeter and the voltmeter have been synced into a single uh, instrument which we call the fluke meter. That is one of the most used meter in the industry. In the same line, we have the voltmeter. We've spoken about that, and now to the diode. A lot of us will be wondering what diode is. Simply put, a diode is a semiconductor device. It functions as a one-way current switch. It permits current to flow smoothly in one direction. However, it limits current flow in the other way significantly. In the same line, we have the inductor. An inductor is a passive electrical component. It stores energy in a magnetic field briefly when current runs through its coil. We've got the induction motor, or different use cases for inductor in the industry. The same way we have the battery. Nearly everybody knows what the cell is. So the battery or a cell is an electric power source. It has one or more electrochemical cells with external connections for powering electric devices. This is being used in the home, in the industry, across different places. We've got the resistor. This is a rheostat. The resistor is being designated as this in London. A passive electrical component. A resistor is a passive electrical component or an electronic component that has two terminals used to control or regulate electric current flow in electrical circuits. The primary function of a resistor is to lessen the current flow and voltage in a specific region of a circuit. It reduces the current flow and voltage in a specific area in the circuit. If that is clear, we've got the light dependent resistor or the photoresistor. It is abbreviated as LDR. A light dependent resistor, LDR, or your photoresistors are electrical components used to detect light. Once light is detected, the LDR may be designed to alter the operation of a circuit significantly based on light presence. In the same line, we've got our ground or heart. When you are looking at line diagram or an electrical design, you are going to be seeing different designations for all this. This is the ground or the head. The ground or the head, we call it a reference point where voltages are measured in an electric circuit. It is like a common return channel for electric current or a direct physical connections to the heart. Like this potentiometer, this functions like a resistor as well. However, when you start changing it, let's assume now that you want your vibration to be in reference to the potential to the resistance. The more you increase your potentiometer, that is the lower the resistance will be. The more you reduce it, sometimes the higher the resistance may be, or vice versa. The frequency may be, or vice versa. What you see here is your wire and your cable. We say a wire is a single conductor, but cable is a collection of conductors. This in itself is a fundamental distinction between wire and cable. Phototransistor, as you can see, that is a phototransistor. A phototransistor in many light detection circuit design, phototransistor is a kind of a bipolar transistor that is sensitive to light, and that's the gain of a transistor. Uh, they are widely used because they are significantly more sensitive than the photodiode. As we move on in our channel, in our discussion on this channel, we get more acquainted to most of these components. Then here we are, we're going to be talking about, as well, we have electric motor designated as M. Designated as M. An electric motor is it is designated as M in a circle, just showing that something is, it is designated as M in a circle. In contrast to an electric generator, an electric motor is a device that transforms electrical energy into mechanical energy. Its works are based on the principle of electromagnetism, which demonstrates that when an electric current is present in a magnetic field, a force is actually applied. The torque that is produced by this force on a loop of wire in the magnetic field allows the motor to rotate and do productive work. Applications of motor includes motors find usage in fans, in power tool appliances, electric vehicles and hybrid vehicles, and beyond. It is largely used in the industry for pumps, for conveyor belts, and a host of other things. We have our AC source, an AC source or an AC power source. It's a unit that can provide a load with varying power and frequency. It imitates electrical grid outage, harmonic surge, or other phenomenon that might lead to a device under test malfunctioning. Under test malfunctioning, an AC power source delivers an alternating electric current that powers our test, that powers or tests a different piece of equipment. As well, we've got a contactor. A contactor is essentially used in the industry, like you all know. Its functions are in electrical switching. It is employed to turn on and off electric circuits. While it is a unique kind of relay, like I always say, contactors and relay functions fundamentally different. Relay, in its own sense, is utilized for lower current application. However, contactors are often employed in applications involving larger current carrying capacities. They are small and simple to mount in the field. The majority of the time while the contactor coil is operated, the contacts are generally open and supply operational power to the load. Electric motor uses contactor in the industry. As well, we've got overload. We're looking at this, the thermal overload. We're looking at it. An overload is a relay. It is a relay. And it has a safety function of guarding circuit against harm, which is caused by high power load. In order to prevent damages to the circuit, the relay opens if the load reaches a specified threshold. So, upon knowing this, we are going to be finding most of these diagrams, most of these components in our electrical designs, in our electrical drawing. After learning everything about most of what is required of us about electrical designs and about electrical drawing, line diagrams, I think it will be of great advantage if you can start designing as well. We are going to find a day to teach us about electrical design, and that will make it easy for us to just apply our knowledge here to designing electrical diagrams, into designing line diagrams for industrial uses. And I think that will help us a lot. This little tutorial will lead us to some other things from our previous discussion, and that is we are going to explore further on line diagrams and how to read line diagrams. On continuation from our previous line diagram discussion or tutorial, so to say, we will move on from there onto this page. If you look closely, put your eyes on one, you are going to see 4 wires. The 4 wires are the red, yellow, blue. Red, yellow, blue, the neutral, and the head. So move your eyes to the point designated as 2. You are going to see circuit breaker 3, which is a 10 amp. Then it goes on to the Allen-Bradley power flex inverter, or simply put, a variable frequency drive, like some will say a variable speed drive. You can see that there's an IP on it, on the VFD. What that means is that the VFD is connected to the Modbus RTU. It has got an Ethernet IP, which gives it a connectivity to the Modbus RTU. It has to be programmed in line with the PLC and some other stuff. That is on the point label 3. But however, on the point label 4, you are going to see some output U42, 43, 44 coming from T1, T2, T3, or UVW, and it goes on to something we can see here. We can see this is a fuse that is not incoherent. However, we can also say it's a contactor that is not incoherent. If you go on to 6, you can see something like a breaker. You can see that is a contactor, or simply put, a breaker. Upon that, you can see an electric motor. It can be a breaker, and as well it can be an overload. However, going a little bit down to the point 7, we've got 2 7s. You can see an electric motor. That tells us that the other time we were saying that electric motor is designated as a cycle with M boldly written in it. If you notice very well, that is a cycle with motor, which is has an inscription motor 3-phase. That is just one of the means of designating electric motor in electrical design. Now a little bit up, we did say that you read electrical diagram from top to bottom or from left to right. If you move to the point label 4, you are going to see that's another power inverter, power flex inverter, Allen-Bradley power flex inverter with a different IP. That tells us that it is connected to the Modbus RTU. So if you understand that, you move down, you see 57, 58, 59. The cables goes into the motor 7. It goes into the motor 7. That is the one by your right. And if you look, you're going to see 2.8. Those are the earth or the ground. This is one of the simplest approach you can use to read your line diagrams, your electrical drawing, single line diagram, multiple line diagrams, anything like. Just follow it methodically using this pattern, and you are going to understand. Each cable is numbered starting from 1. From the point at label 1, you are going to see that those are the points with labels 1, 2, 3, 4, and E. If you move a little bit downward, you are going to see CB3 10 ampere. So, which is the circuit breaker 3. It's a 10 amp circuit breaker. You can you're going to see that the cables going into the circuit breaker is 2 and 4. However, the ones coming out is 40, 41. So it goes into the power flex inverter, which is L1, L2, PE, and so forth. And then it comes down the UT1, the T1, T2, T3 that goes to the motor is for label 43, 42, 43, 44. If there is a fault now, you know how to look for 42, 43, 44, which is an output of the inverter being fed. From V1, T1, T2, and T3, 42, 43, 44, goes into the electric motor, goes into the breaker, then from the breaker out into the electric motor, or you can see from the overload. However, you just try to have a look on what is being used there. If you can easily see 42, 43, 41, you are going to understand this particular design, this particular diagram, or this particular component is being designated as this. However, the likelihood of it being a contactor is very high, or it being a breaker is very high. Just have a quick look and just check that way before moving on to another. I think we've discussed a lot on this, and this is enough. If you have any question, you can always send me a message or you comment in the comment section. I look forward to seeing you again. Thank you for always being a listener. I appreciate you. Bye.